Good afternoon. Looks like we have a lot fewer people here today. Don't know why. Must be the rain. Any questions? Okay. I want to point out that there is a homework assignment posted. It's pretty simple. You have to do a couple of diagrams, and it's due on Sunday night. After that, there'll be more substantial homework where you have to do some actual coding, and I'll be posting that before the weekend in case you want to get a head start.
Wait, so you mean we'll get one more homework this week?
Oh yeah, there'll be homework every week.
No, I mean except this homework here.
No, the next homework will be due okay.
in
2.5 weeks,
Okay.
from maybe 2 weeks from now.
Okay.
And if I can figure out how, I'll break it up into 2 stages. I'm still working on it, so I don't quite know. But that one will be a genuine programming homework, and then the ones afterwards will also all be programming for a while. For those of you who yearn to code. All right. So let's see how we're doing on the reading. Let's get into Piazza. So go ahead and look at the slides for today and read the first question while I clone this one here. 4. All right, here we have them all. So last time we talked about this Piazza-like system, and some of you had drawn these CRC cards, and that was taken the cards from the names from the cards that we discussed. So one person reported have had a card named Post and a card named Response. And so I want to know what is the relationship between them in these technical terms that were covered in the book. Get the app on here. Eight votes so far. Let's try 5, 6, 7, 8, 12, 13, 14, 15, 16, 17. Now we have 21 people here, so let's get that a little up. Yeah, those of you who voted, feel free to peek at the next question so we get through those quickly. So I would like to have a few more votes here. Like at least 3 more. More. Guys. All right, so one. Okay, so that was kind of mixed. So 9 people said 1, and 7 people said 2, and the others didn't find so much favor. So let's see. So that's interesting. So a lot of people said dependency, and a lot of people said aggregation. So let's understand what that means. Aggregation is pretty easy to understand. Aggregation means that when you have a post object, that it has in some way a response. So if you were to look at, say, the object of a post, and you look at what a post object looks like, it would probably have a text field, and it might have like an answer field, and if that leads to a response object, then that would mean aggregation. That would be evidence for genuine aggregation. Right? A post object has a response object. Dependency is a little bit more nebulous. Dependency means that a post object in some way does something with the response object. So the way that I would like to explain it, if you think from a programming perspective, if the post class would not compile without the response class, then they clearly depend on each other. And that dependency could mean, like this, aggregation is a form of dependency. So in a way, you're never wrong with saying dependency because it covers aggregation. But dependency could also mean that there's some method in the post class and maybe it has a parameter of type response. And then it would do something with the response. I don't know what it would do. Invoke some other method on it. So if you have a situation like this, then the post class depends on the response class because it does something with the response object. It would also be possible for the post class to construct a response object and do something with it. Then it would also depend on the response class. But if it doesn't do any of that, then it would not depend on it. So in this case thing here, of course we never quite know how the implementation is. It is possible that the implementation stuffs everything into a database, and that instead of having an answer object here, there would just be the ID of the answer in another table. In that case, then there would be no aggregation. But that's probably not the most likely implementation if you were to do this in Java, as you will, in fact, for homework number 3. You're most likely going to come up with a design where a post object really has a response object sitting in there. In fact, there's two, one for the instructor and one for the student. Yes?
So in the case you have a response object as a parameter of that method, is that also aggregation?
No, this is only dependency. So sorry, so this here is aggregation. And this one over here is only dependency. So the dependency is here.
I mean, aggregation says that if there's another object in the object of the original class, which response is an object and it exists in this class.
It doesn't exist in the class. It's passed as a parameter. So you need to differentiate between objects and classes. So when I look at a post object, and a post object manages a response object, then that's aggregation. But here you don't have object, you're talking about the class. If one of the methods of the class manipulates objects, then that's not necessarily, that's just dependency. Like as another example, dependency on system.out. If somewhere you call system.out.println, That means you depend on system.out, which happens to be a class print stream, so you would depend on the class print stream. But if you don't actually store system.out anywhere, then there's no aggregation, which you almost never do, right? You just get at it when you need to. So dependency is much more common than aggregation, in fact. And so some people initially only track dependency and then they later worry about aggregation. With our simple examples, it's a useful distinction. So here, in this case, my vote would be for aggregation because in a reasonable normal implementation, I would really make it so that a post object contains a response object. But as with all of these things, one can always think of someone who comes up with a design where that's not the case. So that's the beauty of it, that you're almost never wrong. Except with inheritance, that I think is wrong. Unless you take the attitude that a post is a special kind of a response, but that doesn't really make sense, right? Because there's some posts that are not responses, namely the initial ones. I mean, by no reasonable definition of response would that be. Now, you could say maybe it was the other way around because I didn't really clearly say one is what, right? Maybe a response is a special kind of a post. So if that was the interpretation that you had in mind, that would be a valid thought of inheritance, right? In that case, you would say post is the more general class, the superclass, and response is the subclass. And so I could understand that representation. No, sorry, that interpretation. And did anyone vote for none of the above? I'm sure someone could come up with some interpretation why that is true as well. So I wanted you to think about these different kinds of interpretations. So in the next question, what I want to get after is whether you have looked at the various kinds of arrows and can correctly interpret them, which is kind of a necessary skill. So assuming what we've just discussed, where I said, the thing is supposed to look like this. So under this model here, which of these arrows is the right one? Well, just tell it to me in Piazza. Because someone might disagree with you and quietly record that in Piazza. So let's do it real quick. All right. So here voting was fast and furious. All right, so here we have the votes. And the good news is that there was a vote for the right answer. The right answer is 4. So why isn't the right answer 2? It's going the wrong way, exactly. So this was mean and underhanded. That thingy here, that diamond, for no particular reason, it's just what the notation people came up with, has to be sitting on the class that does the containing, that does the aggregating. So it has to sit here and not here. And you simply have to remember that. There's no rhyme or reason to it. Why a diamond in the first place? So just remember that when you draw the aggregation, that the bigger class, the one that contains the smaller one, that's the one that has the diamond, and the other one doesn't. That's right. Right. What would this have meant? What depends on what? Does post depend on response or response on post? Post. Yeah, post depends on response, right? And so here the arrow is kind of like the normal way. It's just with this one's where the arrow is the other way around. So this would mean that post is a subclass of response. Right? It's a special case, a general. It specializes response. So you simply have to remember these arrows. There are a few other arrows that are in the book, like the containment where this diamond is filled in, And I've never found the distinction between aggregation and containment, all of that, useful. In a language like C++, where you don't have reference semantics for objects, you could argue that it is a little bit more useful. But in the context of Java, this is good enough. There's also this concept of association that I think it's pretty nebulous, and some designers love it. But these three concepts, I think, are easy to understand. They clearly map to what we know in terms of programming. This one is just inheritance. This is containment in some way, and this thing here just means won't compile without the other. So those are easy to understand, and they're good enough to model anything that we will encounter in this class. You should know that some people take this more seriously and have other distinctions, but this will be good enough for us. All right. Now here we have a sequence diagram. And so unfortunately, it's a little hard to fit on one slide. So I have a bit of code, very simple code. I'm reading something from a file. I read each line and I print it up. And then I drew a sequence diagram, and I purposefully made at least one error. And I want you to tell me what that error is. So maybe I can make this a little smaller so it all fits. Here we go. This is one that I really want everyone to try, because I didn't, when I taught this last semester, and I hadn't been teaching this course for quite a while, I'd forgotten how hard sequence diagrams are to understand. And when I asked in exams, draw me a sequence diagram, I got the most adventurous and creative sequence diagrams that I had ever seen. They were just, almost all of them were plainly wrong. So this semester I want to make sure that everyone understands the syntax perfectly. They're useful enough that we really want to understand how they work. So give it your best shot. All right, now this is very interesting. Okay, so it looks like there's wide disagreement on this one, and I think that proves the point that they're more intricate than one at first thinks. So let's have a look at this really carefully. So this is some code, and we don't quite know where it is. So I just say that whatever the object is that carries out this word, I just don't know what it is. It's something like this is this timeline here that goes on that deals with this. So I have a call to new scanner as new scanner. So that's obviously this construction call here. There's nothing mysterious about that. And so then this here would be the body of the constructor. And this is something that goes on inside the body of the constructor. Of the constructor of what? The constructor of scanner. All right, that's the body of the constructor called new file reader. We don't think so, right? Because there's already a file reader passed in. So this call here, the new file reader, should have emanated from somewhere here. So I'm try this one more time to see if I can draw on the slides. There we go. So there should have been an arrow, a create arrow right here and not here. And that would have been better. So one is definitely wrong, but it could be that all of them are wrong, right? So let's look at 2. The scanner doesn't call read on the file reader. Okay, so now we are in here in the has next line, and we're wondering, it claims here that the scanner's implementation of has next line calls read on this file reader. How would we know? How would you know? Do you have any idea what has next line does for the scanner?
What?
Yeah, we're right now inside the call of has next line. So here, this code here, the one that we see, so it calls in.hasNextLine. Now that's a method of the scanner class. Have you ever looked at the implementation of scanner.hasNextLine?
Yeah, doesn't that actually consume one of the lines?
Yeah, what it does is it needs to consume one of the lines. It needs to try to read it, right?
Yeah.
And so, yes, in fact, it will call read.
Okay.
Because how else is it going to know whether there is another line? Yeah.
Shouldn't the has next line should point to the scanner handle because it's initiated by to call the.
Okay. So let's understand where these lines go. So
The second one has next line. Shouldn't it be under the scanner, the panel? It originates from the Office system you haven't labeled.
right. So this code that we don't quite know what it is invokes has next line on the scanner.
Well, we say in is a scanner object.
Well, so you have to see what is the invoking code. That's the code here, the one in the yellow field. And it's of some object. We don't know what that object is. So that code calls the has next line method on the scanner. So maybe it'll be clear when we look at the next one here. So now this scanner call here, we claim calls read on something. We don't actually know what that object is. It's some file reader. Notice that it has no name because we don't know the name. But so that's very important that you understand what does the origin and what does the target mean. The arrow points to the object on which the method is being invoked. So over here, we are invoking printon system.out. And we're invoking that from this unnamed object here that we don't quite know what it is. And yeah, is it confusing? I guess you get used to it. I mean, there's this kind of action that represents the code that goes on in here. And then one assesses, well, what happens here? So at this point here, we're calling has next line. Here we're calling next line. Here we're calling printon. And on what do we call it? On this object. On this object again, because it's in and in twice. And then on system.out. But that's an excellent question, right? Because we really need to have a very clear grasp of what this notation means. Another question? All right. So now here it says 3. The call to printon should originate with the scanner. So the critique was that maybe the arrow should have gone from the scanner to here. Well, where should it originate from?
What did you say it shouldn't originate?
Where should it originate from?
I know, but where did you say it shouldn't?
No, I'm saying should. Okay. The 3 says it should originate from here. My picture says it should originate from here. So which one is right? That's my question. Should this line here that goes to system.out Should it start at this blank object, or should it start with the int object? That's what choice 3 seems to say.
I think it's correct. It should especially this picture.
Okay, so you think it's correct? I think it's correct too, because this code here, the yellow code, is what is represented by this thing, and there's a call system.out.println from here. This here really is the yellow code, and it calls system.out. Yeah. So then the correct answer is 1, right? And that was what's, a minority of people did say. So these things are harder than you think. That's all that I want to get across. So no one needs to feel bad. I just want to get everyone to realize that this was maybe not quite so trivial. So before we go into yet another fun lab, let's briefly go through the slides that I want to cover. So we talked about these relationships, and so it's super useful to be able to remember them as users has's, because those are very intuitive things. Users is clear to understand. Has for aggregation and is for inheritance. That an instructor is a user, for example. So there's this notion of coupling. When one class depends on another, then one says the classes are coupled. And a common example of coupling is with printing. We generally want to reduce coupling, because whenever you have fewer dependencies, then it's easier to evolve a system, to move it elsewhere. And so a common example is printing. Suppose you have a method that's called print, and it prints something out to system.out. Now that's not so great, because now you have coupled your class, whichever it may be that does the printing, you've coupled it to system and to print stream. And you might say, that's rather academic, who cares? But there is a more important reason why coupling with system.out is bad. There are many, many systems that run Java, such as this guy here, or a smart card. Have you seen a system.out in here lately? Your phone doesn't have a system.out, right? So if you have code that says that printing has to happen to system.out, then you're saying this is code that only works in a regular computer with a terminal attached to it, where system.out has a meaning. So that's not so great. The remedy is simple. Make it so that instead of having a print method, you have a method getText or format object or some such thing, where you simply generate a string with the same information that you would have otherwise printed. Then that way, that string, someone can later decide what to do with it. Put it in a dialog box, or if one is on a system with a terminal, then they can print it. But then that decision is deferred, and your class becomes more usable. So that's just a simple example for minimizing coupling is good. The less unnecessary dependencies you have, the more usable your classes are. So if your class doesn't depend on system.out, if it doesn't depend on print stream, you can move it to environments where that dependency would not be useful. So aggregation is not something that people usually have difficulties with. The one thing to note is that aggregation, it's always useful to capture multiplicities. If you have a implementation like this, then you would have either one-to-one relationship or 1-to-0 or 1 relationship. So here this mailbox, depending on whether greeting could be null or not, it's one or the other. If on the other hand you want to collect lots of things, you need to have some mechanism of collecting them, for example, here with an array list. So for right now, we'll use array lists for just about everything, either lists or maps. And of course, there are other collections. So inheritance, we're going to be covering in great detail later in the course. My hope is that you've had at least a lecture or so of inheritance in Java at one point. In 46A, 46B, there's just a little bit of it. It's not a super important thing, but there are a couple of examples. And so inheritance basically means that you have a class, and then you want to specialize it in some way. So the example that I have here is there might be some class message in the mail system, and then maybe I want to be able to forward a message, and the forwarded message is just like a message, in that it can be stored in a mailbox, but it also has some other information, like the name of the person or the number of the person who forwards. And as a negative example here, greeting is not a subclass of message, because you can't do things with greetings that you can do with messages. Like, it makes no sense to store greetings in mailboxes or send them from one mailbox to another. All right, so now I want to talk about this UML notation. So in the heyday of object-oriented methodologies, there were multiple notations invented to draw up relationships between classes and so on. And then 3 of those notationeers got together, formed a company that later was bought by IBM, and they unified their disparate notations to this UML notation. And then UML grew by leaps and bounds, and people added other diagrams and all sorts of crazy overhead and meta language that's not really used very often. But the basic diagrams are kind of a common notation that everyone needs to master. So we'll just cover really 2 diagrams. I don't think we'll even do state diagrams in this course. We'll look at class and sequence diagrams. They're far and away the most common ones, and really everyone needs to have some basic understanding of what they are and needs to be able to produce them. So class diagrams are pretty simple. That there's 2 forms that we will use. There's the very simple one where you just have a box with the name of the class inside. And then there's a more elaborated one where you have the name of the class in the top compartment, and then you list so-called attributes, I'll talk about that in a minute, and methods. Now, there are some automated tools that will look at your code and make you a class diagram that lists every single method, right down to equals and hash code and toString. That's not useful. So whenever you draw one of these more elaborated diagrams, you should only put in those things that are of interest for whatever reason you draw the diagram for. So there's always people who think that it brings good karma to draw these diagrams, or that it's just a checklist, that's something that you have to do to get to fulfill some requirements. And that's not usually a good idea to do that. You would always want to draw a diagram for some reason. And so the best use for a diagram is you're there talking to someone else and you need to explain something. And there's a general fog that people are a little confused about what are all of the classes in the system. And then it's common for people to just go on the whiteboard and sketch out, and just so that everyone has the same background, draw this diagram. And at that point, people might talk about that there is, say, some user ID or some text string or somewhere that's floating around somewhere. And then it would be very common for someone to just draw a box like here and just write user ID or text or whatever the attribute that they're discussing in there. Or they might talk about a specific method that needs to be fleshed out. And then they would put just that method in there. But never all methods and never all properties. So that's the spirit in which you should see these diagrams. And we'll practice that in the lab. So what exactly is an attribute? That's another one of these fuzzy notions that you should think of an attribute as something that has a getter and maybe a setter. Sometimes they're called properties. It doesn't have to be an instance variable, but it could be an instance variable. So it's something that a user of the class needs to be able to read and may need to affect in some way. But an example would be the posts in Piazza have a timestamp. How do I know they have a timestamp? Well, you don't actually get to see the timestamp, but it says, Fred Flintstone said 5 days ago. So for Piazza to figure that out, obviously they're not continuously updating all of these objects from 4 days ago to 5 days ago. The object just remembers when that post happened. And so that means that when you want to talk about that particular feature of Piazza, then it makes sense to say, okay, you have a post, and that post has a timestamp. So you would just draw it like this. And that's potentially interesting in some context. How is that timestamp exactly realized? Does it count seconds from midnight from when Earth was born or something, or is it a date string? I have no idea. And so we're not really getting into that detail, but we know that somewhere there is this timestamp. So we've talked about class relationships, and you see here the zoo of arrows. We only care about the top three. Yes?
So on the previous slide, I think on one of the previous diagrams, you showed that mail greeting is you showed how mailbox has a greeting instance where
Okay, that was an object diagram. That was not a class diagram.
Yeah, but in this UML, are we supposed to write in the attributes that greeting is an attribute?
Okay, I think I understand the question. Let
I
me.
think that's in the book, so it
Yeah.
could be.
Okay, let me answer the question that I wanted you to ask, and we'll see if that answers your question as well. So this was like in a mailbox, and so the question I think that you have, and if not, the question that I want to answer is the following. Which of these two should you use? And that really kind of depends on what greeting is. If greeting is just a string, if it's simple, just a string say, then I would use the first form. Then I would just say it's an attribute. If greeting is a big complicated thing that somehow that it by itself has like fancy behavior and that I'm interested in tracking, then I would use the second one.
So does that imply that UML is not supposed to talk about or detail all the information about it?
Well, the rule, the function of a UML diagram is to illustrate some other point that you want to make. It is a tool to talk about the software design. It's not an end in itself. So it's not that UML should be like in some way record or document your code. It's just there as a way of drawing something, and you put in as much or as little detail as is useful for the point that you're trying to make. And so when I draw a UML diagram and draw another one tomorrow, if the context is different, they may come out different because I want to emphasize different things. So in the homework, I'm asking you to draw a UML diagram of various classes that are used for a Piazza simulation. In there, the focus that I have in mind is to help with the implementation, to help understand which fields do you need to put in, and which lists, for example, that kind of stuff. So that's the interest that I have in the homework, because in the next homework, that's exactly what you're going to be doing. All right. So the other thing, when you do aggregations, it is useful to indicate what multiplicities you had in mind. So here I say that a message queue can have an arbitrary number of messages. It's a one-to-any relationship. Sometimes you have a 1-to-1 or a 1-to-0-1 or a 1-to-2 relationship. There was somewhere I had one with two. Like I think a mailbox had two message queues. One for the new messages and one for the used messages. So put that information there. It's generally pretty useful because it tells you, do I use an instance variable, do I use an array list for implementing that, or maybe two instance variables in the case of the new and the used messages. Or in Piazza, when you have a post, it has two responses. It has one from the students, or as I say, collectively from the students, and one from the instructors. So in that case, I would say there's a 1-to-2 relationship between whatever their posts or questions and answers. All right, so we're not going through any of these. We're not talking about interfaces. Yeah, and I already said this. So don't draw a single monster diagram. I've seen people who try to do that. I've seen people who would get an A1 plotter paper. Like a humongous sheet that they roll out, and it has like the UML diagram of the entire system. Complete waste of time. because who's going to look at it? Who's going to understand it? I once had an engineer who loved doing that, working for me. And so what I would do is I would close my eyes, point to a random spot, and say, explain this to me. More often than not, he would roll up the thing again and say, oh, you have a point. I don't know what the point I have, but so apparently he saw more into this diagram than anyone else on the team did. But that's not usually good use of time. So at the time, the UML was new, and we all felt, maybe it's good for that. But now we all know it's not. UML is a great notation for when it makes sense. All right. So sequence diagrams, we talked about that. The calling thing is on the left. The object on which a method is being invoked is on the right. So in other words, the call that's being illustrated here is new messages dot add, and then there's some parameters in here, and we don't get to see from the diagram what the parameters are. Why does one draw these things at all? You usually draw a sequence diagram if there's some non-trivial and maybe hidden part of the control flow. It's very common to do that when you have complicated constructions such as iterators, where the iterators point into some secret parts of your object and you don't quite understand what they're doing. We'll have a lab with that. And we'll see in a bunch of other scenarios where it's just useful to know who calls whom and whom, how does a chain of complex things evolve. For very trivial scenarios, one doesn't normally draw these diagrams because it's work to draw them. They're intricate things, and if there's a mistake in them, they're hard to fix because everything needs to be moved up and down. So you would only draw them when the cost of drawing them is worth the price. And so I used to think, the last semester I said, we'll never draw any trivial ones. And then I paid the price for that when in the exam, when I had people draw a non-trivial diagram, they couldn't do it. So we will draw a few trivial ones for practice, or fairly trivial ones anyway for practice, so that everyone really understands the notation. But then in your project, don't give me 20 sequence diagrams of things where you could just give me a snippet of code instead. So generally, a sequence diagram is only worth it if you couldn't, with much less pain, just write 4 lines of code. And for, a short diagram is always easier. Like, looking at this thing is clearly easier than this. It's easier to read, it's easier to write, because we all know how to read code. So they are somewhat specialized, but they do have their purpose, and it's a notation that we need to understand. All right, so then here you have like a cute little self call. So this method here calls another method on itself. And so here you see the lifeline of the first method, the one that we don't quite know what it is. And here you see the lifeline of the locate mailbox method. And that's how it is. Here's the construction that we already saw. And so one other thing that I should mention is if there is a loop, suppose for whatever reason one calls add 5 times, you don't normally draw the loop, you don't normally draw it 5 times. So a loop is kind of implied. That because each of those calls is likely going to go the same way. If you happen to have something where you know that the last call goes differently for whatever reason, that might happen with like has next, where the last call is different, then you might want to draw like a representative one of the first kind and then the last one. All right, that's all I want to say about diagrams. So we're on to the lab. So I want you to do a couple of things, and I want you to do those on the whiteboards here. So we have plenty of whiteboards. I'll erase this so we have that one as well, because that's what people commonly do. And what I would suggest is that we do this in teams of 4 today, because otherwise there won't be enough whiteboards, and it's just good, clean fun anyway. So merge into teams of 4 in some way, and just draw up some of these diagrams. And then it shouldn't take very long, in 10-15 minutes, then I'll walk around and we'll talk about them. And after that, I want you to draw a sequence diagram. That one, again, you can do it in a large number. One of you needs to have a laptop ready because you need to actually understand the source code for one thing. And then we'll talk about the sequence diagram and see what to do with it. In terms of proving that you've participated, the easiest thing is all of you just take a photo of it, and then you just put it in your in your folder, because in the repo, because like I said afterwards, and so I think these instructions are bad. There's no report.txt this time. Yes. All right. So ignore the report.txt. Just each of you, take a photo of your creation and with your friend standing in front of it, smiling, and then put it on the side. That way, I have a bunch of samples and I have proof that the lab was done. Okay. You need whiteboard markers, and I have a whole bunch of them here. Yeah.
How many people?
Sure. So, like, how about the four of you form a group? No. You want to do it on the whiteboard. There's a whiteboard. There's one right here.
Okay.
Did anyone want this picture? Let me just take a photo of it. Okay, go ahead and erase that and use that. And there's more back there. You guys can share a whiteboard. You use this. You guys use the one back there. Okay, You only have 2 people? Well, how about then grab one of these people. Like, how about you go with them? Then we have 3 and 3. Okay. You guys grab yourself some corner of the whiteboard.